In today's NVIDIA RAPIDS data science demo, we're going to show a 25 times performance increase of XGBoost training, inference, and feature engineering with pandas, all accelerated with NVIDIA RAPIDS running in Google Colab. We'll start off showing how to enable NVIDIA GPUs within Google Colab. Then we're going to take actual taxi fare data provided by the city of Chicago. We're going to build a mean and median models as our baseline. And then we're going to try to incrementally increase our accuracy using XGBoost and feature engineering. XGBoost and NVIDIA RAPIDS come pre-installed in Google Colab. In the description below, you'll find a link to a Google Colab notebook of this demo so you can follow along. Let's get started. NVIDIA RAPIDS and NVIDIA GPUs are natively supported in Google Colab. I'm going to show you how to enable your GPU and enable NVIDIA RAPIDS. It's very simple. The first thing we're going to do is we're going to say change runtime type. You can do it this way. And you can see I'm currently on CPU. If you're on the free tier, you'll see this T4 GPU, and that is more than enough to run this demo. I'm on the Pro tier, so I have a couple more options. Another way to get to this menu is to click this drop down and again, change runtime. My favorite way is these two plots that show the system resources. If I click this, I can see I only have system RAM and disk and no GPU right now. This is the third way to change the runtime type. I'm going to go with an A100 to keep things as fast as possible. I'll click save. Now this is going to restart my session. If I had any work or any variables, they're going to be cleared out within my workspace in my session. All right, so I have my GPU. It is running, and there's a few ways to verify that. If I click NVIDIA SMI, I will be greeted with this page, and I can see I have an NVIDIA A100, the 40 gigabyte memory version, and I have CUDA 12.2. I can also run the NVCC, the CUDA compiler command, and say -- version. And this also lets me know that I have an NVIDIA GPU and the proper drivers are installed. And the third and easiest way is, again, click this right here. And now I can see I have a GPU RAM 0 out of 40 gigabytes. We haven't done anything in the GPU yet, so it is currently empty. All right, so we've enabled our GPU. We verified the drivers. Now we want to turn on NVIDIA RAPIDS. To turn on NVIDIA RAPIDS, really simple. We just do load ext QDF pandas. This will work on, if you have code right now, if you have pandas code right now, putting this command at the very top will accelerate it. You don't have to change any code. So now that we have this running, we can do a few more things. We can verify the version if we need to. So we can say pip freeze, pipe that into grep QDF. I can see I have QDF -Q12, Q12, Q12. That looks good. There's another way to do this, and if you import, actually let me put that below the QDF load statement. So if I import pandas as PD, you have to run this command anyways. And then I run, let's see here, whose. This will list all the variables I have. And since I only have this import statement, I just have this PD. And if you see this fast QDF, that means you are using accelerated, NVIDIA RAPIDS accelerated pandas. All right, whoops. Now that we have that, we have our GPU, we have the drivers verified, we have loaded NVIDIA RAPIDS for pandas. Now we want to make sure we have the right version of XGBoost. To determine the latest version, I'm going to go to rapids.ai. All right, and then I'm going to click Ecosystem and scroll down. You can see all of our open source acceleration libraries, and then you're going to see the products that we are integrated with, and you see XGBoost right here. I'll go to the GitHub page. Scroll down a little bit and you can see 2.13. This is the latest version. Another way to do that is to go to tags. And again, 2.13. Let me close that, close that. All right, so now that I know that 2.13 is the latest version, again, I can run this pip freeze, pipe it into grep XGBoost, 2.13. Things are looking great. Another way is to just go ahead and import it and print the version. And there we have it again, 2.13, amazing. All right, so that's all it is. Again, the easiest way to enable your GPU is to click right here, change runtime, and choose the GPU, and then to load NVIDIA Rapids, run this command. If you do this on your pre-existing code, it should work. As long as you put that load ext cuDF at the top, you don't have to change any of your pandas code. On to the next section. All right, now it's time to get our data and get some baseline or naive modeling done. You can download this data yourself. It's open source data from the city of Chicago. And this is the data set in their data portal. We can see we have trip ID, taxi ID, some timestamps, the length of the trip in seconds and the length of the trip in miles, some drop off and pickup, geography data, and then our target or our dependent variable here is trip total. This is a regression problem. This is a supervised learning, machine learning exercise, a few more extra features and some more geography. All right, if you want to download this yourself, you click export, choose the file format you want, and click download. I've already downloaded this, and I've already put it into my Google Colab. My Google Drive. I'm going to copy it into my Google Colab session here, and I'm going to see that it is almost 2 million rows. This right here, we'll get into this in a few minutes, but this is all it takes to accelerate XGBoost with NVIDIA Rapids. Just like pandas is that one command, XGBoost is just this one parameter will accelerate XGBoost. So we'll go ahead and run that. We're going to do some imports, very simple. Now to do our baseline modeling. I want to point out here that pandas read CSV is a GPU accelerated or NVIDIA Rapids accelerated operation. You can see that took 1/3 of a second. Without NVIDIA Rapids, it took 22 seconds. And then this is just a little bit of light feature or data preparation, a little shuffling. All of that together is right here. And in case you're not familiar, if you put this % time header in this cell, you'll see this CPU time. We can basically ignore that. That is the amount of time the CPU ran in user space and in system space. Since we have more than one core, the total was 375 seconds of CPU time. The one we care about is wall time. This is the time that we perceive. All right, so we've got our data loaded. Now we'll do some baseline models. We'll start with the mean. The mean of the entire set is $17.58. I'm going to do 5-fold cross-validation or K-fold cross-validation with 5 splits or 5 folds. And with that, we can see our metrics are this right here. I'm going to focus on mean absolute error since it's the most interpretable. That means our average error is $13 and almost 40 cents, and our max error is almost $10,000. That'll become clear in a second. All right, now onto the median model, and the median is almost $10. So we'll do that 5-fold cross-validation, look at the results, and see if we got any lift here, and we did. The median error or mean absolute error is almost $3 cheaper than the mean model. So if we are data scientists at a rideshare startup, we are improving the quality of our product. The max error is about the same, a few bucks cheaper. All right. So now that we have our baseline, we've loaded our data, we have our baseline models. it's time to try and get some lift with XGBoost. Now that we have our data and our baseline, it's time to use XGBoost. And I'm going to start off with just no parameters, no hyperparameter tuning, no feature engineering to show the power and simplicity of XGBoost. So I'm going to go ahead and load the data, and I'm going to get rid of some data leaks. I'm going to get rid of the features that total the target, and I'm going to get rid of the IDs and some extraneous non-numeric features just to keep it simple. And because again, we're still kind of doing a baseline. And now I'm going to do this k-fold cross-validation. But if you look in the middle here, if you look right here, these 3 lines of code create the XGBoost model. So this instantiates the class, the XGBoost regressor class. This trains the model or fits the model. And then this predict does the inference. All this other stuff is just k-fold cross-validation and gathering the metrics of the model. So I'll go ahead and run that. And looks like it takes between 5 and 6.5 seconds. And then nice, took 5.25 seconds. And then we're going to look at the results. And we can see, and I call this XGBoost naive because I haven't done any real feature engineering. And it looks like we got a lot of lift here. We got $5 of lift. Our mean absolute error went from $10.50 to $5, and our max error is still pretty high. It went down $200, but that's pretty good. All right. Now we're going to do a little bit of analysis. One of the really nice features of XGBoost is the feature importance plot. There's a few different flavors of it. I'm going to just use the default one. I'm going to do weight. You can also do gain and cover. And we can see that the time and the distance of the taxi ride were the most important features for predicting the fare. All right. Now we're going to do a little more in-depth feature engineering. I'm going to load the data. I'm going to look at the variables, look at the number of uniques to see if any categorical features are hidden inside as numeric columns. I'm going to do a little bit of cleaning here. I'm going to impute missing values. And let's see here. I'm going to, again, sort to look at just to get a visual. And I wanted to point out here, we have these weird outliers. We have these $10,000 or just under $10,000 cab fare rides that have 0 miles. And this is just strange. This seems like some outlier. So, again, I'm going to go ahead and do a little more feature extraction, but I'm also going to get rid of these outliers using the modified z-score. And I'll go ahead and get rid of those outliers. I'm going to take the features that were given and do a little extraction, especially for the timestamps. I'm going to get the day of the week, the hour, month, year. And lastly, I'm going to encode the categorical features, just very basic encoding, nothing fancy. Again, take another look, and we can see the trip total looks a little more normal. All right. Get rid of the nulls and the infinite values. And again, I'm just going to use the very simple kind of default XGBoost right here. I'm just going to fit to the data that we have, and I'm not going to do any sort of extra parameters to the XGBoost. All right, so that takes a few seconds using NVIDIA RAPIDS. And if we look at our lift, see that took 6.5 seconds. We got major lift. So we got major lift using XGBoost out of the box, and we got even more lift using a little bit of feature engineering with XGBoost. We'll go ahead and plot the feature importance again. It's really pretty plot here, but if we were really, data scientists at a rideshare startup or something, we would use this and go reevaluate and then maybe reduce our feature set to get a more generalized model without sacrificing accuracy. All right. Now we're going to take that XGBoost and do a little bit of parameter tuning. At the bottom of this notebook, I have a full-on hyperparameter optimization code if you want to play with that. That's how I got these numbers. And you can see I'm going to build more estimators. I think the default is 100. I'm going to lower the default from the default learning rate. And I'm just going to do a few more metrics here that I did from tuning in the code below. And that is going to take, let's see here. That's going to take about 14 seconds. And once that's done, we'll look at the results. All right, that took about 13 seconds. And just like typical machine learning or data science, we got very little lift, right? The closer we get to the information that the data holds, the harder it is to get that little lift. And we can see with just a little bit of parameter optimization, we did get lift, but not much at all. Looks like, fractions of a penny, although the max error went down $5. So that's pretty significant. All right. That was XGBoost in a nutshell. On to the next section. All right, now for my favorite part where we do rapids on, rapids off. All of the code we've done so far, I've taken it and I put it into this single cell. And this is to kind of simulate a week in the life of a data scientist or analyst. And you can see all of the different modeling exercises are all in this single cell. None of this code in here, all of this code will work without rapids, right? This is code you might have right now. And to accelerate it, all we need to do is run this magic command for pandas and set this parameter for XGBoost. Now we'll go ahead and run this. And you can see I've done a few preliminary exercises here, but I'll go ahead and run this. And one nice thing is if you see this little green arrow, I don't know if you can see it. Whoops, it just disappeared. It's going too fast. All right. So that took 10 seconds. So I'll go ahead and put 10 seconds up here. And we know that as we do these sorts of things, the longer it takes, right? If you go fit a model or train a model, if it takes a second, you sit there and you get the results right away. If it takes, a long time, you're going to get up and go get a coffee or a lunch or a tea or whatever. So having this lets you build more models and improves your accuracy. All right. So I'm going to do rapids off. I'm going to turn off the GPU, switch to CPU here. And this is going to restart my session. All right. So now I need to comment out these two lines and let XGBoost train with the CPU. And of course, I have to move my file over because, again, when you change the accelerator, when you turn the accelerator, the GPU off, it restarts your session. Do my imports, and now I will run this code. All right, this is a week in the life of a data scientist. And I want to show another cool feature of Google Colab. I didn't do the percent time to record this one. I'm just doing a time here. And you see this little green arrow here? If you don't have that time function, you can actually see what line is currently executing. That's really cool. So now you can see now we're reading this CSV. We're not doing the read CSV GPU accelerated. So it's going to take a little bit longer. And this whole thing is going to take around 2.5 minutes. So I'll go ahead and pause the video right here. All right, it's finished running, and the time it took with Rapids, NVIDIA Rapids off was 226.7 seconds. And so in this case, it was more than times 20 faster. It was 22, 23 times faster with Rapids on. And all we had to do, again, to get that times 20 or times 22 speed up was this command and this parameter. I think that's well worth adding that one parameter. So there you have it, 25 times performance increase with NVIDIA Rapids within Google Colab. One command for pandas, one parameter for XGBoost. Please leave us your questions and feedback in the comments below. Don't forget to click the link in the description for a Google Colab notebook of this demo. Cheers and happy coding.